So hello, I'm Joseph. I'm the lead developer of Onyxia, an open source software developed at Insee, the National Institute of Statistics and Economic Studies. And I'm here to introduce you to Onyxia. And afterward, Lino and Quentin will show what they've done with it to create two amazing platforms. So Onyxia is an open source software solution for creating data science platform. It's a web application that you deploy on a Kubernetes software, on a Kubernetes cluster. The idea behind Onyxia is to enable organization to provide to their team robust cloud-based work environment for data science. So Onyxia addresses significant challenges that arise when people work on data science directly on their computer. Data gets duplicated all around the place, significantly increasing risk of duplication. There is also the fact that it's hard to share results and reproduce work when everyone's configuration is unique. And lastly, when you try to, with a single computer, there's only so much that you can do. You're capped in terms of processing power. So the solution is to work on web-based environment where resources can be shared and the IT team can strictly restrict the network policies, and containerization can be leveraged to make sure that we get rid of the problem. It works on my machine. Solutions like JupyterHubs are great as they provide an easy to deploy and easy to use environment for Jupyter. But the landscape of data science is much broader than just Jupyter. So when you try to interact with cloud-based technology at a lower level, things get immediately inherently more complex. Like, for example, compared to when you work on your local computer, when you work on the cloud, suddenly you don't have a file explorer with files that you can simply open. You have to fetch them from remote APIs. You also have to think about how can I, how to free resources when I'm done using them. This is something that you don't have to think about when you're working on your local machine. You have to shut down your containers. But if you do that and previously you haven't pushed to Git, then you lose your work. And what about resuming your work? Do you need to set everything up again? So these challenges are especially daunting for people who aren't particularly tech savvy and who just want to focus on their work. In Onyxia, each user has its own Kubernetes namespace, its own S3 bucket, and its own Vault directory for storing secrets. The UI is very transparent about what's going on behind the scene. So the idea of the interface is just to make those technology more approachable by providing button to press and form field to fill instead of requiring command line input. For example, with a simple click of a button in Onyxia, you can launch a pre-configured S3-enabled PySpark environment. So the key benefit of this approach is that your environment can evolve as long as the landscape of open data science evolves, because it's a constantly changing landscape. So when you launch a service with Onyxia, it's just a graphical representation of a name chart catalog. And organization can provide even their own business-specific services just by creating standard M packages. With Onyxia, you can launch anything. You can launch, of course, Jupyter, but also PostgreSQL, MLflow. Really, any technology can be used through Onyxia. So when new tools emerge, it doesn't make your data lab obsolete as long as Kubernetes and Helm remain relevant. So let's see in practice what it looks like. I'm going to show a little video to, okay, pardon me. All right.
Leveraged it to create two amazing platforms. So Onyxia is an open source.
Sorry, there's ChatGPT that is speaking in the background. Reading my script out loud. All right.
Data science.
It's still speaking.
Onyxia
All right,
addresses
all right,
several
all right. I'm terribly embarrassed, but just play along with me just a second. I have to understand where the sound is coming from. Okay. Okay, thank gosh.
Onyxia.
Okay, so there's over 50 existing Onyxia instances around the world, and now I'm gonna hand it over to Lino, who will introduce how we create amazing training courses available to all French students and beyond with Onyxia.
Thanks a lot, Joseph. Yeah. It's going to be hard to come after this amazing video, so sorry about that. Yeah, thanks. So, as you might see, I'm an enthusiastic user from Onyxia from a long time, first for my data science project and then afterwards for my teaching. But I'm also terribly independent, so you will see I will give you my full opinion on Onyxia. Well, first, as data scientist, I'm working at Insee, the French National Institute of Technology. We are experimenting a lot data science techniques. And before having an Onyxia instance, we could not work on the data science fields. We could do regular work, but we could not, make innovation. Because to experiment, well, as a data scientist, you know you need freedom. You need to be able to test a library to know if it's interesting to dig deeper. You need the possibility to connect Python, which is a fabulous API, to other more specialized softwares. For instance, you need to be able to connect Python with Postgre, you need to connect Python with a vector database, with MLflow, and in standard infrastructures, you can do that. You don't have the right. If you have the right, it's quite complicated. It's not a data scientist job. It's more like, sorry, maybe I was talking too close. It's not a data scientist work. It's more like data architect work. So As a data scientist, you can't do that in standard environment. Afterwards, after experiment, well, you go into production. Well, if you've worked on standard infrastructures, it's also a terrible pain to go from experiment to production. Well, with Onyxia, with our instance, we could experiment because we had the freedom, but we also had all the tools needed to make going into production easier. And that's why we could foster innovation, we could adopt data science at Insee more easily thanks to the Data Lab platform. But then I became a teacher in data science, mostly in engineering school. I started to write a website, a very complete website built with Quarto, which is really beautiful, in my opinion. But well, when I wanted the students to start working, they needed an environment which is quite the same, the one I needed as a data scientist. They needed to be able to execute code, to install libraries, etc. Maybe later on their educational curriculum to connect Python with more technologies. So in fact, I just needed a data lab for my teaching. And I needed in particular VS Code or Jupyter notebooks. I mean, notebooks on Jupyter or VS Code. Problem with that is that, well, universities or engineering school often provide an environment. It is based usually on desktop installations, and in fact they are usually creating more problems than solving problems. In particular, well, students usually they go on their computer, they log in, and they don't have everything they need. So they start to install things. They are beginners, and they are asked to install Python, or if Python is here, they are asked to install Anaconda or things like that. So it's really bothering them and leading them to abandon the class because, well, they don't practice, in fact. They just spend time configuring an environment they don't understand. So it's the first problem. And you, if you are a teacher in that scenario, well, you have to manage many environments because students will start to install softwares on their computers, but their computers, it's their environment, and it won't be the same as the one of their neighbors. And you will have to understand why they have a specific error. Is it because they mistyped NumPy as NP? Or is it because they just installed a wrong package, or I don't know. So it's quite natural to go to standardized environment with web services. Well, you know probably one which is Colab, Google Colab, but I'm going to have the strong claim that we prefer using SSP Cloud, which is the data lab implementing Onyxia. Well, why not going to Colab? Well, Colab is free, but if it's free, you're probably the product. It means that, well, first, students will have free access to computing resources, but if they want premium features, they will have to pay a fee, for instance, for GPU. It means that when they will want to go to machine learning and especially neural networks, when they will need that kind of resources, they will have to pay. We don't want them to give them the first pill as teachers of introduction to data science. Data Lab is providing GPU, as Joseph told you, and it's giving you all the environment required to train model or do infer using models. But also, and I think as a teacher, it's my main the main thing I don't like with Colab, it's the integration with Google Drive. That makes them save their programs and their data on Google Drive. And if they do that, they don't practice Git, they don't practice cloud storage they will need to do in the future of their in enterprise. So we don't want them to be accustomed to that. We want them to be accustomed to state-of-the-art practice. And that's why I don't want them to use Colab. Happily, SSP Cloud is providing the same advantages of than Colab, meaning it's easy to launch a Jupyter notebook with a standardized data science environment. But you have more. You have access to a wide range of open source technologies that are used in state-of-the-art firms. In particular, they have access to MLflow, to Postgre, to S3 storage. They have access, meaning that they are not locked in using these services. If they want, they can ignore them. But if they want, they can also use it, and it has been pre-configured and interacting quite well with Python. So that's the idea in terms of philosophy of using SSP Cloud for teaching. And I might maybe have 1 minute to do the presentation, to do a demo. Hop. Tu veux aller sur le SSP Cloud? Là, si tu cliques sur hop. So showing you well, how easy it is to handle. So just to show you, I have that course on my website, and I'm going to launch it as a notebook. Up. Sorry, I'm not used to Mac. It's taking a little bit more time, something like 1 minute. It's not instant container creation, but you will see the same content, and my students, they do that at the beginning of the class. If it's not ready Alors, c'est pomme V, c'est ça?
All right.
Yeah.
Non, pas enregistré.
All right.
Okay, let's go.
And now you can see they have access to Insee computing power after clicking, but they also have access to more things than in Colab, for instance, terminal, where they have lots of writes. They have access also to S3 storage, etc. So that was the idea of using SSP Cloud for teaching, and now I leave the floor to Comte, that is going to show you a re-implementation of Onyxia in his own lab.
Thank you, Lino. So I'm Quentin Godel. I work at Mercator Ocean International, and I will testify how we adopt the Onyxia platform in the context of oceanography science. So especially in my project, we are talking about digital twin of the ocean, a big word, fancy word. I will just explain a bit the context and why it was relevant for us to take Onyxia apart there. So what is the digital twin of the ocean? Simple definition that I like: an interactive replica of the ocean for simulation of future scenarios and better decision making. So basically, what is really important here is the interactive part, which means that we have somehow a service that is available where we can interact and we can generate data by deciding, for example, what will be the temperature of the ocean in 30 years if the CO2 level in the atmosphere does not decrease. And this is actually, if you wonder about that question, today it's a bit complicated to understand. Okay, you have to read the IPCC report and so on. But if at some point we want to have faster decision making at the policy level, we need some interactive tools for the policymaker to be able to change actually the value, to not maybe they have other questions than this, but we want the result to be scientifically valid. So up to now, what you can find in around is okay. You can find observation from the Earth, from in situ data directly in the ocean, and so on. You can access the data. It's stored somewhere, shared by the institutes that are mandate for that. You can also access sometimes the model data that are from the physical model of the ocean or deep learning model of the ocean. And you can visualize the data. That is really, really something that we can do today. You can access a viewer where you can find the data that you wish, the information that you wish on the ocean, and extract it. And then there is something. Because when you want to extract some ocean data, we are talking about terabytes of data. So you cannot download that, actually, okay? And if you want to post-process that, if you want to do smart engineering over it, well, what we want to do is to do that where the data is, okay? So we need somehow a data lab, but that is running online near the data. And based on that, the scientists could work, and then we want them to be able to expose what they've done. The process that they've built, we want them to be available as web API so that software integrator, software developer can integrate that with software, modern software application, modern UI, and then we can present that to the policymaker so that they can access that. They don't have to know about the dirty stuff that we have built under the hood. They have the fancy UI for them, a simple one, but the data and everything that is doing under the hood is scientifically valid. And that's where we have been mandated. That's what we have been mandated to create. So we create a web application that is called Edito. And basically, we want user, like developers, scientific, to think as if they want to find something about the ocean or work on the ocean, they have to go straight to that platform. That platform contains different kind of interface, like visualizer, the regular one, but also a data lab, which you can guess which kind it is, that allowed like advanced UI for doing scientific stuff and software stuff. So it's an evolution of Marine Data Portal. As I said before, we have our users that are exploring the ocean data, maybe have some lightweight computation on the fly. That is something that we can do depending on the formats that we use. But we want them now to be able to create new data on the platform, near the data, derive the data that are heavy data. And in the end, we also want them to be able to contribute to this digital twin option, to contribute to the community by exposing their data, their work to the outside world. So on the right part, it's everything that I've told so far, except maybe that we also have some use case really interesting is that we have a lot of scientists working on supercomputer. So we have to manage somehow a seamless link in between our web cloud, a cloud cluster that is based on Kubernetes and the supercomputer world. So that is something quite challenging, but it's not the purpose of the talk today. So how we adopt Onyxia? Well, so that is, I already said that, I think. We have our viewer that is not Onyxia. We have our data lab that is somehow Onyxia. So now it's a fork of Onyxia. I will explain why. And we have also used another platform that is developed by the team, not as part of Onyxia, but it's also something that is really nice, a tutorial platform that we use. So first, we install Onyxia, and we fully customize it for our need. So this is the same instance as Onyxia with a custom theme, and we were able to do that without even contacting the team in the first place. So that means that it just worked, okay? You have a Kubernetes cluster, you have the possibility to install some keycloaks, some S3, some mini IO or something like this, and you follow the tutorials, it worked. Then, as I said, we have our own viewer that comes from our own ecosystem. How we integrate that with the data lab, how we can facilitate the uptake of the data lab by our user. Well, it's just simple, actually, because everything that you can do in Onyxia, you can script it with just URL with parameter in the URL. Everything is really easy to replicate. So we generate this URL and we integrate that in our metadata in the viewer, so that here you have some links. It doesn't trigger a bell to you, but if you click, it launches a Jupyter notebook with good context for you to be able to exploit the data that the scientist is actually looking for. So he can use the visualizer to search over the data, select some piece of images and so on, and then just in a click go into a Jupyter notebook or a studio or something. Then we were able to do that, of course, without the help, because it was easy to do. Then we were trying to do something else. We want to add more services, our own custom services. So that's services like Jupyter and so Studio, VS Code, but that embed like some, for example, some Python libraries that are really popular in our field, such as Xarray, Conda, library to manage our data formats that are NetCDF or ZAR. And we were able to do that quite easily because we are able to do that. We are not the users that need some fancy interface. But then what we wanted to do is to propose to the user to add their own service. And that were quite a challenge because we have to teach them about the underlying standards that we use, Kubernetes, Helm, and so on. But actually, it was actually well received. We have a lot of users that are used to Amazon Web Services or Google or Azure or even just OpenStack deployed there and there. And it's complicated when you want to deploy something, then you have to think about a virtual machine. Then you cannot just do that. You have to think about the network that the virtual machine will be. So, okay, why? Why not? But then the network policy before creating the network, and so on and so on. So in fact, you are just getting away from your actual purpose, your actual job. And with Helm, that is the choice of Onyxia, it's just not like this. You just copy paste something that exists, you quite understand how it works, you change the URL of your container image and it works. You don't even have to care about the certificate or the URL and so on. Everything is just, I mean, we have a lot of good feedbacks about that. So we were able to do that without contacting the team. So far, no fork, everything is on our side. Then something that, well, we are running under the hood on OpenStack on some unknown cloud provider, and we have trouble to enable some features there. And then at some point, we needed help on the infrastructure part because we are not operators. And actually, we just asked them because they are expert in Kubernetes and so on, and they were really nice, and they just explained how we can configure some parts so that we can optimize the resource usage, such as the GPUs and so on. So they were there for us. Then we wanted to add some more features, something that is not in the Onyxia-based product, which is like process. So here the goal is there is a scientist that comes to the platform or have like a really nice mathematic function, and he just wants to expose that to the world. Just say, I've done something to detect marine heat waves in the ocean. It's an expertise. It's a scientist that has this expertise. How can I propose this service? I mean, the compute to the world. How can anyone detect marine heat wave over the latest data that have been produced yesterday, and tell him, okay, what are the marine heat waves today? So they are able to do that. I have to go fast, right? Okay, I go fast. Conclusion. It's easy to talk to the team. No, this is not the conclusion, sorry. This is just to say that we are also working with the team on the future evolution of the platform. They are actually really contacting us about decision making and so on. So that's great stuff, and we can always talk to them. They have community calls, so you can join. It's easy. There is a Slack. People are nice in there. Here is the conclusion, the feedbacks. For us, it was just easy to deploy Onyxia. They are nice, they are reactive, and they listen and they propose evolution to its community before actually implementing them, as what you expect from an open source project. As a user of our platforms, they just say that it's really intuitive. We never have people asking us about anything except maybe some bugs reports from time to time. And yeah, they can install whatever they want, and that is totally a game changer in our field. As a contributor, well, they think, and we think, the Onyxia team choices was good choices about the standard, and they can just use the platform also as cloud providing, so that's a game changer as well. And I think that is all that is really pertinent. Thank you to the team.